In this video, we will go over the valid anagram question and algorithm. The problem tells us given two strings, s and t, return true if t is an anagram of s and false otherwise. We are also given the definition of an anagram, which is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all of the original letters exactly once. In other words, both strings need to have the same count of the same letters. The algorithm I am thinking of is to first go over each letter in string s, and create a map of each letter and the count of times that the letter appears in the string. Next, we will go over each letter in string t and check if the map doesn't contain it, or if the count of that letter in the map is 0. If either of these conditions is ever met while our algorithm is running, then we can return false. Each time we hit a letter that is in the map, we will decrement the count associated with it. After that, we will go over each letter in the map. If it has a count other than 0, we know that we haven't used all of the letters, and therefore the strings are not anagrams. Else, if the count of all the letters in the map is 0, we know that the two strings are anagrams. In this video, we will go over the answer and explanation to the valid anagram coding exercise. Up at the top of the code, we will include the string and map header files, since our solution will make use of strings and maps. Inside of the isAnagram function, we'll first create a map that has strings as keys and integers as values, named letters and counts. For each character C in our string S, we will create a string named C as string, and pass 1 as the first argument in the constructor, and C as the second argument in the constructor. Next, we will have an if statement that checks if C as string is not an existing key in our map, which we can do by using the count function. If the key doesn't exist in our map, we will add it to the map and assign it a value of 1, since this is the first time we hit that letter in the string. Else, we can increment the value in our map since the letter exists as a key in the map. This for loop builds a map that contains each character in the string as a key, and the count of the times each letter appears as the value corresponding to that key. The next step is to iterate over each character C and T, the other string that is a parameter that gets passed into our function. Inside of the for loop, we will create a string variable named C as string, which will be the character C converted to a string. We will pass 1 in as the first argument to the constructor, and C as the second argument to the constructor. If we hit into a letter that does not exist in the dictionary, or whose count is 0, we will return false, since that means that we don't have one of the letters we need in string S to make the string T. Else, we will decrement the value of C as string in our letters and counts map. After that, we will create an iterator for our map of strings to ints, named it. We will iterate over each key in the map and check if the count of any of the letters is not equal to 0. If that is the case, we will return false, since we know that there is a letter left over, and therefore the two strings s and t are not anagrams. At the bottom of our function, we will return true, since if the code gets to this point, we know that the two strings are anagrams. When we run the code to check our solution, notice that it is correct.